All right, this is number 61 on section 5.3, and I redid it because most of the previous video I did was okay. It's just that at the end when describing the answers, I kind of messed up, so I want to correct that. All right, so when we're looking at this, they're telling, here's how I have to kind of read this. I see this x divided over 4, and I'm like, ooh, that's going to make it tricky, and it does. But here's what I do. First of all, I'm going to think about a simpler problem. I'm going to think about what would it be if it had said cosine of some angle is 0. Okay, so I know that since it's 0, it's going to be somewhere on the unit circle, one of these 90-degree kind of increments here. If I look at the points, remember the cosine is your x value, so I'm looking where is there an x value of 0. Well, that happens right here. I've got the point 0, 1 for pi halves, and then down here I've also got 0, negative 1, and that's, I'm trying to make that look right. That's 3/2 pi. So I've got two different angles. So if it had just been this problem, my answers would have been pi halves, and then again I can go all the way around the unit circle, right? So I could put that as plus 2 pi n. And then the other answer I would have gotten was 3/2 pi plus 2 pi n. Okay. Now the thing about these answers that I want you to notice, there's a better way to describe them. Maybe I don't want to do it that way. I want to do it a more succinct or pithy way. If I've got an answer here, instead of going all the way around just 2 pi to get there, if I just go around pi, there's an answer. If I go around pi again, there's another answer. If I go around pi again, there's an answer. I could describe all my answers as pi over 2 plus pi times n if n were an integer. It could be a positive or negative whole number. It could even be 0. That would give me all my answers, okay? So what I can do then, since both of those values have a cosine value of 0, that means the x-coordinate was 0, this would be all the answers to this problem. But that was not the problem I had. I had this x over 4. So here's what I'm going to do. To adjust my answer, I'm going to take that x over 4 and I'm going to set it equal to what would have been my answer, pi over 2 plus pi n, because I'm going 180 degrees every time to get to a new solution. And again, n is element of z. All right, so how am I going to find my solutions? I'm going to solve for x. Here's the x. So what I need to do to get rid of x divided by 4, the opposite of dividing by 4 is multiplying by 4. So I'm going to multiply everything by 4. So that means pi halves gets multiplied, multiplied by 4. And pi n gets multiplied by 4. And then just n element is z. So that's x is equal to 4 pi over 2. That becomes 2 pi plus 4 n pi n element of z. The book may describe it differently. That's the quickest way to get an answer, the quickest way I know to describe it. The book sometimes does strange things about the way it describes the answers, but this is a correct answer. Let's move to 60. So for 63, we had the problem sine of 4x is equal to 1. Okay. Now, for a minute, again, I don't know how to think about this 4x, so let me for a minute make it a simpler problem. I'm looking for the angle who has a sine of 1 on the unit circle. And, on the unit circle, this is 1, 0, negative 1, 0, 0, 1, 0, negative 1. And the sine value is the y part of the coordinate point on the unit circle. So there's only one answer that has a y of 1 here, and it's this pi halves here. Now, if it were just one trip around the unit circle, my answer would have been pi halves. But I know that I can just keep going around the unit circle. So if I kept going around the unit circle to describe all those answers, it would have been pi halves plus 2 pi n, where n is an integer. It could be a positive or a negative number. It could be 0. Okay. Now, the problem is that would be my answer if this were the question. Sine theta is 1. But it's not the question. I had this 4x. So what I'm going to do to solve for it, I'm going to take the 4x, that was the argument here, and I'm going to set it equal to what would have been my answer over here, the pi halves plus 2 pi n. Okay? Now, I need to get x by itself. I could divide everything by 4. You can divide by 4, you can multiply by a fourth. I'm going to multiply everything by a fourth, just because I've got a fraction over here and I like looking at it that way better. You could do whatever you want to do as long as it ends up correct. So what I end up with is a fourth times 4 is x. This pi times 1 is pi, 2 times 4 is 8. Over here, the 2 goes into 2 once, the 2 goes into 4 twice. So I end up with the answer pi over 8 plus pi over 2 times n, where n is an integer. This exactly matches the book. We had done this in class, and what I had done, I set the 4x equal to the pi halves first. In like the year 2016, who knows what year it is if you're listening to the video. I'd set it to equal to that first and then added the 2 pi n, but I actually have to describe all the solutions to this problem first and then set that equal to 4x. That's the adjustment we had to make.